Very good evening, sir. Am I audible?
Yeah, audible.
Thank you so much, sir. Thank you so much. A warm welcome and very good evening to all dear participants. A resource person of today's session, respected Dr. Anil C. Mathew, sir. Yesterday, he delivered one session on basic concepts of regression. Now, today we are having our session on use of linear and logistic regression. Few participants are not presented in last class. I again take only 2 minutes time to introduce sir. Sir is currently working as a professor of biostatistics at PSC Institute of Medical Sciences and Research, Coimbatore, the Tamil Nadu Dr. MGR Medical University. Sir has been actively engaged in teaching and research in applied biostatistics for 3 decades and reviewer, member of editorial committee of various national international journals, include Indian Journal of Medical Research, American Journal of Epidemiology, and BMJ Online. Sir was an invited participant in the Indo-US workshop series on clinical research organized by US Embassy, New Delhi during 2007 to 9, a statistical expert for preparing the course material of the Applied Biostatistics course of Indira Gandhi National Open University in 2011, a statistical expert of the Task Force Committee on Geriatric Research, Indian Council of Medical Research in 2011, member of the Expert Award Committee of International Biometric Society, Indian Region in 2012, a statistical expert for the INCL-EN WHO pentavalent vaccine safety study in 2013, and many more. In recognition of the eminence achieved by way of his outstanding contributions leading to the promotion of statistics in medicine, Dr. Anil C. Mathew sir has been conferred on fellowship in medical statistics of the Indian Society for Medical Statistics for the year 2017. Dr. Anil C. Mathew visited several countries, include Bangladesh, Malaysia, Sri Lanka, Kuwait, Nepal, Oman, Indonesia, and UAE for chairing scientific sessions and organizing short courses. Now, with respect, I invited to sir, please kindly lead today's session. Please, sir, welcome, sir.
Thank you, Dr. Amit Tiwari, Dr. Padam Singh, and Dr. Shubham Pandey. Thank you. Again, it is a great pleasure for me to be with you these 2 days. And today's session, which I am taking, is just a continuation of what we discussed on yesterday. Yesterday, we were discussing on the basic concepts of the correlation and regression, especially when we are dealing with the two continuous variables. What is the meaning of regression analysis? It is basically meant for predicting the independent variable for a given value of the dependent variable. Sorry, predicting the dependent variable for a given value of the independent variable. Today, we are going to discuss more on multiple regression and multiple logistic regression. Is it audible? Is it audible?
Yes, yes, sir.
Yes. Okay.
Audible, sir.
Yeah. Yesterday, what we have discussed is for a simple linear regression. Just can you take it out from this session? Okay. For simple linear regression, we use the formula for a straight line. That means y is equal to alpha plus beta x. For a given value of x, what is the value of y? And alpha and beta is what we will be determined based on the regression methods. One of the methods which we discussed yesterday is on least square method. But today we are going to discuss on multiple regression. For multiple regression, we include more than one independent variable. And for each of the new independent variable, we need to add a new term in such a model. That means the x1, x2, xk, we are certain independent variables are there. And this independent variable and their relationship with the dependent variable, which is called y. And we are connecting this through a regression model, which is called y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus etc. beta k sk. This is actually what we are going to study in this particular session. Okay. So the population parameter y is equal to beta naught plus beta 1 x1 plus beta 2 plus dash 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 plus beta k sk, where betas are the coefficient for the independent variable in the true or population equation, and the x's are the values of the independent variable for the member of the population. Whenever I discuss with this multiple regression analysis, with my interaction with the PG students of the medical students and with my interaction with the postgraduate students in the university, 70 to 80% of the students did not understand some of the rationale behind the multiple regression analysis. Remember, please, this multiple regression analysis, we may have to look in three different ways. That's the first thing. The first way which we are looking is identifying the factors which are related to the dependent variable. For example, we will be doing a study on body mass index. We are having several factors. We can have more than 20 or 30 factors. The notable among them are calorie intake, protein intake, physical activity, age, so many factors. We can look into it, more than 20 to 30 factors which we are looking for, fast food consumption, etc. So many factors, beer consumption, so many factors which we can look into it. Out of all these 50 variables or 30 variables, which are the variables statistically significant to this body mass index? That is a part of the analysis which is called the multiple regression analysis. That's one part of it. Second part of this multiple regression, what we will looking at, especially when we have a data of a prospective study or a cohort study. For example, we have been following patients. For example, the patients may be coming for the master health checkup today, and we are having the values of a certain cohort people of today and or this month data, and we will be following them for a 10-year, 5-year period or 10-year period. And we know the outcome also. Based on this outcome, we will be able to predict a regression model, predictive model. That means that model will help when today a patient come with an age, say example 25 years or 30 years, with a BMI of 32 as BMI, and with certain parameters which we are looking. What is the chance that he is going to become obese or he is going to get a myocardial infarction? This is a second way of seeing the multiple regression analysis. The first multiple regression, what we will look into it, which are the factors significantly associated with the dependent variable. That's one way of seeing it. Second way of looking the multiple regression analysis, second studies, especially when you do a cohort study, we are more concerned in getting a prediction equation for the multiple regression analysis. That is the second way of looking into the multiple regression. And we have one more way of looking into the multiple regression, especially that is actually what we call it as exposure outcome relationship. The one best example which I can tell you is an oncological study. We have been doing a standard treatment. A new treatment came into the picture, and we would like to know whether this new treatment gives better survivorship than the standard treatment. As you already know that for a cancer survivorship, the treatment is not the only one factor. There are so many factors play a role. The age of the patient, the number of nodes removed, the stage of the cancer patient, so many factors play a role. But adjusting, we call those factors as confounding factors. Adjusting the effect of this confounding, is this the new treatment gives significantly better survivorship compared to the older treatment? This is also, we call it as a multivariate analysis. So basically, in a summary, what I would like to tell you, multivariate analysis, basically we have, in practical point of view, we have to see three types of multivariate analysis. One is for a given dependent variable, what are the factors significantly associated with the which are the independent variables significantly associated with the dependent variable. That's one way of seeing it. Second way of seeing the multiple regression, second situation where we use multiple regression analysis is among the factors, how we can get a prediction equation based on the multiple regression. That's the second way of seeing it. And third use of the multiple regression is in the exposure outcome relationship. how to adjust the confounding factors. We will look into these things in this today's session. At least I will try to explain some of the things in a very short way. So conceptually, multiple regression is a straightforward extension of the simple linear regression procedure. And simple linear regression is a bivariate situation that it involves two dimensions, one for the dependent variable y and one for the independent variable x. Multiple regression is a multivariable problem with one dependent variable and multiple independent variables. Actually, if you look into the medical field, if you look into it, this multifactorial etiology is very common, especially after this non-communicable disease, when we start doing research. In communicable disease, okay, one-to-one relationship, somewhat we can discuss about it. But when we look into the non-communicable disease, it is a multifactorial etiology. That is why this multiple regression becomes more popular. We usually call a term called the modern epidemiology. So here we have an example of a simple example which I would like to explain. The dependent variable is body mass index. We would like to know which are the variables significantly associated with this body mass index. And the factors which I am considering in this data is age in years, fast food consumption, exercise, BH per day, and calorie intake per day. There are so many other variables also there. But this is just an illustration only for easy understanding. And this data is actually called as cardia data. From that only I have taken this data. And we would like to know, out of these 5 independent variables, which are the variables significantly associated with the body mass index. Here is the data set. Usually, we keep the first column as the dependent variable and rest of the columns as the independent variable. Here, age, fast food consumption, exercise, beer consumption, and calorie intake are the independent variable, and BMI is the dependent variable. So first thing when you wanted to do all regression analysis, we have assumptions are there. Especially if you wanted to do a multiple regression analysis, the assumption basically focusing for the dependent variable more than the independent variable. So the main assumption for doing multiple regression is the dependent variable should follow normal distribution. But if you wanted to do a Poisson regression analysis, the assumption is the dependent variable should follow Poisson distribution. And if you wanted to do a logistic regression analysis, the assumption is the dependent variable should follow binomial distribution. But here the dependent variable is body mass index, and we are interested in doing the multiple regression analysis. The first step is whether the body mass index in the data which we are having, whether it follows a normal distribution or not. So we plotted the normal distribution plot, and conventionally there is a small statistical test. There are so many statistical tests are available to look into the normality of the variable. And one small test which I have used in this data is Kolmogorov-Smirnov test. And if the statistical test is not statistically significant, if p-value is not statistically significant, we can say that this variable is following normal distribution. So accordingly, in this data, BMI follows a normal distribution, and hence we can use multiple regression analysis in this data set. So for using this multiple regression in the SPSS, we have to open this box, and the first thing what they will ask you is what is a dependent variable, and I have mentioned as BMI as a dependent variable, and independent variables which we have mentioned as age, fast food consumption, exercise, beer consumption, and the calorie consumption. So we have to keep these variables as the independent variable. And we have option is there in the when you have this method, we have several 5 options are there. And if you are only interested in finding out the significant variables alone, the best option for us is enter is the best option for us. But on the other hand, if you are wanted to get a prediction equation, you can use any of these things, forward, backward, or stepwise. There are 3 regression models. Conventionally, we will be using these 3. But here, first thing what we will look into it, out of these 5 independent variables, which are the factors statistically significant. So just to give enter command. So once we get this enter command, the first output will be like this way. They will say model output, R-square value, and then they will say you get a table called analysis of variance. So what does this analysis of variance will tell you is, if analysis of variance, if the regression value, if it is statistically significant, it is the first to give information for us that out of the 5 variables, one of the variable is statistically significant. That is what it tells to you. There are so many ways which we can interpret it, but I am an applied biostatistician. So for an applied biostatistician, what this p-value indicates is, suppose if you are considering 20 independent variables, if this regression coefficient is statistically significant, it indicates this is a positive result for us. At least out of the 20, at least one variable is statistically significant. They are telling you this good news in advance to us. So accordingly, when you perform the variables, these are the 5 columns which we are going to get it. Unstandardized regression coefficient and standardized regression coefficient, and each regression coefficient, the t-value and the p-value. We are going to check what they told, what the ANOVA tells is correct or not. We can just have a look into the results. Yes, it is correct only. We have 2 variables, calorie intake and fast food consumption. These 2 variables are statistically significant. And the fast food consumption, the p-value is 0.001, and calorie intake p-value is 0.001. So this is the important information what the ANOVA table will tell you is, before seeing this result itself, it will tell you in advance a good news. Like some children will come and tell us a good news, somebody is coming or some cake is coming, like that way. This is a good news for us that one of the variable is going to become statistically significant. So the ANOVA highlighted in the green box at the top of the next slide test hypothesis that in this scenario, F value is 17.323 and p-value statistically significant, indicating how the evidence that at least one of the beta value is statistically significant. Now we are having other informations also. One is the R-square value in the regression equation. So R-square value, here it is, they are also giving 86.1. But how they are getting this 86.1? It is just a division of the regression sum of square with this total sum of square. 120.6.82 divided by 140.188. If you divide these 2 values, we are getting this R square value. What does this R square indicates? 86% of the variation in the BMI is explained by the variables which we have studied. That is the meaning of the R square value. So as we told, there are 2 types of regression coefficients are there. One is called the unstandardized regression coefficient. Another is called the standardized regression coefficient. If you see it, the 2 types, 2 betas they are giving in the SPSS output. One is called the unstandardized regression coefficient. Other is called the standardized regression coefficient. The unstandardized regression coefficient represents the amount by which the dependent variable changes if we change independent variable by 1 unit, keeping the other variable constant. The usual assumption of the usual meaning of the dependent variable. We have one more regression coefficient usually given the output, which is called a standardized regression coefficient. The standardized regression coefficient is measured in units of standard deviation, and it is used to rank the variables for importance of it. Based on the standardized regression coefficient, we can prioritize which is the variable more important, which is the variable less important. This prioritizing we can use based on the standardized regression coefficient. And as I told you, if you are only interested in identifying the regression models, which are the variables statistically significant, Yender option is the best option. So Yender method in SPS are used to find out the variable significantly associated with the outcome variable. Here, the results are fast food consumption and calorie intake are significantly associated with the body mass index. But sometimes we may use the prediction equation also. But this data which I have given here is not good for prediction equation. As you already know that BMI we can measure on the spot itself. So we don't need a prediction equation for BMI from the data. But at the same time, if it is an expected result for cancer or expected result, expected outcome for a given data, but the person is likely to get this or not. For that is a time which we can more use the prediction equation model. Anyway, for illustration purpose, I just used the same data how to use for the prediction equation. So if the purpose of the regression analysis is to develop prediction equation, the variables do not have significant regression coefficient are eliminated from the equation and recalculate the regression equation using the variables restated. Accordingly, the prediction equation can be formulated. There are three ways which we can use this prediction equation. The first is called the forward selection method, and second is called the backward selection method, and third is called the stepwise prediction method. Usually, these results do not vary much. In forward regression method, identify the variable x that has the highest correlation with the response variable. The next step, what they will do is, the next variable x is one of that increases R squared the largest amount. If the increment in R squared is statistically significant, it is included in the model. The procedure continues until no variable is significantly increases the R square value. So when you do the forward regression equation, also here also, these two variables, calorie intake and the fast food consumptions are statistically significant. Thereby, we can predict the BMI as 0.005 into calorie intake plus 0.364 into fast food consumption plus 12.110 as the regression equation for body mass index. We have other methods also there. The next method is backward elimination method. All variables are initially included in the regression model. The next variable x is one that reduces R square by the smallest amount is removed. If the resulting decrease in R square is not statistically significant, that variable is permanently removed from the equation. The procedure continues until the removal of an x variable from the equation causes a significant reduction in the R square value. When we run this backward elimination also, the prediction equation, there is no difference at all. 0.364 into fast food consumption plus 0.005 into calorie intake plus 12.110 is equal to the BMI of a person. And the last method is stepwise regression method. Stepwise regression method is a combination of the forward and backward selection variables. And this method includes variables which are highly correlated with response variable and eliminate variables that are non-significant. So when you do the stepwise regression, also it's almost exactly the same thing. But out of these three methods, if there's a difference in forward and backward, I will suggest that it is better to look for the stepwise regression method. Because if you look into the history of the multiple regression, stepwise is the latest regression model compared to forward and the backward. Very rarely it happens, but in case you have a confusion, better to go for the results in the stepwise regression. So when you do it, the results do not vary much in reality. BMI is equal to 0.364 into fast food consumption plus 0.005 into calorie intake plus 12.110 is the BMI equation, and R square value is 84.7. So which method is preferred when there is a difference in results? To me, the answer is stepwise regression is preferred as it is relatively new and is more advanced. So we have other assumptions also there. No multicollinearity, no autocorrelation. However, the modern statistical package, especially after 22 SPSS version onwards, they adjust this assumption. Otherwise, we may have to look into this multicollinearity and autocorrelation before running the multiple regression analysis. But the last one more analysis which I just like to explain to you is multiple logistic regression analysis, which is commonly used in regression analysis nowadays. And in the multiple logistic regression, the outcome variable is binary outcome variable. In medical literature, it is widely used because the reason why it is, especially, we have three study designs commonly used. One is called a cohort study, another is called a case control study, another is called a randomized control trial. In case control study, the dependent variable is cases mark control. It's a binary outcome. Independent variables can be several. For example, all the studies related with the cancer risk factors, all studies related with the what is called obesity risk factors, all studies related with the myocardial infarction risk factors. Like that way, all studies related with schizophrenia risk factors, all studies related with the dementia risk factors, everything, the Dependent variable is dichotomous. Either you have dementia or you don't have dementia. Either you are having schizophrenia or you don't have schizophrenia. Either you are having cancer or you don't have any cancer. So that is why this logistic regression is very famous, because there are three study designs. One main study design is case control study. Beyond that, most of the randomized control trials also, we are expecting either yes or no as the outcome variable. Most of the randomized control trials. So the binary outcome is a very common thing in the medical literature. So the analysis suitable, basically this binary outcome is actually what we call it as statistical tape. It is called a binomial distribution. Only two outcomes for it. And the regression analysis accordingly, what we developed is multiple logistic regression analysis. So examples of the binary outcomes are, as I told you, coronary heart disease, yes or no, lung cancer, yes or no, obesity, yes or no, hypertension, yes or no. If you wanted to find out the significant factors for coronary heart disease, or if you wanted to find out the significant factors for lung cancer, if you wanted to find out the significant factors for obesity, or if you wanted to find out the significant factors for the hypertension, the statistical analysis which is used for is called a multiple logistic regression analysis. Here, just giving an outcome, the dependent variable is coronary heart disease. I'm just linking with the bivariate regression, then I will explain for the multiple regression. Here, their independent variable is actually total family history score. They developed a score which is called a total family history score. The assumption is this total family history score, if it is more, the chance of you to get myocardial infarction is more or not. This is a illustration data only. In the reality, you won't get this type of a data. This is totally an illustration data only. So we did a case control study around 6 people control arm and around 5 people cases. Cases means those who are having myocardial infarction as the cases and those who don't have myocardial infarction as the controls. And if you look into this data set, what this variable says is that those who are having scores, myocardial infarction, they will have the scores more than 6 or more than 6 are likely to get MI, and those who are less than 6 likely to get CH. But this is just for an illustration for those who are having for the beginners only. So we wanted to link total family history score is significantly what is the regression analysis between total family history score and the coronary heart disease. What will happen if you do a straight line regression analysis? In straight line regression analysis, y is the dependent variable. In this scenario, y is only have two values. One is either you have coronary heart disease and either you don't have coronary heart disease. So entire y, we have only two values, 0 and 1. And x, of course, we have the total family history score. And as I told you from the previous slide, those who are having more than 6 or more, they are likely to get coronary heart disease. And those who less than 6, 1, 0, 1, 2, 3, 4, 5, they don't get the coronary heart disease. So this is actually data set. Basically in y, for a 1, we will get certain values, and for a 0, you will get a certain values. So if you do a regression straight line regression, it won't suitable to your data set because we have only two values. One for a given value, one we have a set of values, and for a given value of 0, we have a set of values. So what the statisticians did is they tried to make a separate line. Instead of going for a straight line, they tried to join a line like this way. And this line is actually called a S shape. If you see this, the shape looks like an S, English letter S. So if you join like this way and make a line like this way. And this regression, this S-shaped regression line is actually what we call today as logistic regression analysis. So here, just for understanding, the data set of a 9-year follow-up data, and the primary concern is you are having the coronary heart disease likely to get or not. We have the catecholamine value, age, and ECG. These are the three variables which we did it, and we did a follow-up data of these things. So we have to do for analyze, and you have to give option for regression. When you give option for regression, they will give you so many options. In that binary logistic, you have to put it. And the dependent variable is coronary heart disease. And the covariates are catecholamine value, age, and the ECG value. So they will ask you which are the categorical variables. In logistic regression analysis, independent variable can be categorical or continuous. Age is a continuous variable and catecholamine value and ECG are the categorical variables. And here we may have to change the reference category. 0 is no and yes is 1. SPSS will not understand it. When reference category is first means, the number which you have given 0 was the reference category, and compared to 0, what will happen to the variable which you coded as 1? That is the meaning of it. So if you wanted, you can change it, this reference category. So accordingly, when you change it, this is the regression analysis which you are getting. The values which are significantly associated with coronary heart disease are higher age and the catecholamine value, where ECG results is not statistically significant. So older age and catecholamine values are significantly associated with the coronary heart disease. For a bivariate result, exactly the same thing, you can do a chi-square test also. But as I told you, when you do a chi-square test and when you do a logistic regression analysis, the results will not vary much on it. For example, if you there's a data set like a rural areas, diabetes is more or not. It's a 2x2 table. Yesterday we taught on you chi-square test. And chi-square test, the p-value is statistically significant. Exactly, you will get the same p-value even if you do the logistic regression analysis also. So thank you. Just to give a brief outline on the various types of regression analysis, where they have been used it, and comparatively, two regression models which I explained to you. One is multiple regression analysis, and other is logistic regression analysis. Thank you. Time for discussion.
Thank you very much, sir, for a very knowledgeable session. Now I would like to request all participants, then please write your query regarding today's session, either in the chat box or simply raise your hand so I can send you the unmute request. I'm waiting for your queries. Please write your queries in the chat box or simply raise your hand so I can send you the unmute request. Thank you, Dr. Harini. Dr. Archana, thank you so much for positive feedbacks. Dr. Prashant, if you have any query, then feel free to write your query in the chat box. Dr. Sarayu, please unmute yourself. Dr. Sarayu, please unmute yourself. I think he's trying to unmute but unable. Yes, Dr. Sarayu sir wrote a query in the chat box. What if we do not have SPSS software?
Any doubt?
Sir, Dr. Sarayu wrote a query in the chat box. And he's asking that what we do if we don't have SPSS software. He's asking for any alternative.
What if you do not have SPSS software?
Yes, yes.
Yeah, the answer is multiple regression still we can do, but logistic regression we can't do. That's the answer.
Okay.
Because inbuilt algorithm is very complicated.
Dr. Shubha, please unmute yourself.
Sir. Hello,
Yes.
sir.
Yes.
Uh,
Yeah.
Sir, how can we analyze variables in between the groups?
What is the question? I'm not able to understand. Variable in different groups means what?
Dr. Subha, please repeat your query.
Sir, variables from different groups. If we have 4 different groups and if we have to analyze regression between that groups, so how can we do that?
This is which we are telling about the regression analysis, ANOVA output. Hello?
Dr. Subha,
Hello?
is unable to
Sir,
connect with.
Yeah.
Yes.
Yeah, what? Can you
Yes, sir.
explain
Yes,
the
sir.
question once again?
ANOVA analysis is what I'm speaking about. In
Yeah,
between
what
the
I
groups,
told
we
you,
have
yeah,
4
no,
different
it is
groups.
just like giving a good news for us. This
Okay.
ANOVA, if the regression coefficient is statistically significant, it
Hmm.
indicates that a good news for us, one of the independent variable is statistically significant. There are so many statistically way how we should look into something different, but it is for the practicing biostatistician's point of view. That is the message of
Oh,
it.
yes, sir. Yes. Thank you, sir.
Yeah.
If there is any more query, then please write either in chat box. I hope all participants answered their queries. We are receiving various positive feedbacks from the participants. Thank you so much. Thank you, Dr. Sarayu, Dr. Subha, Dr. Resmi. Thank you so much for your active participation in the session. Dr. Sarai Kure wrote a query, sir. We define degree of correlation when multiple independent variables are there. Are we define degree of correlation when multiple independent variables are there?
Yes, the degree of the correlation is measured actually through the R square value. Not directly the degree actually, the amount of variation explained by the independent variable is explained by the R square value. But at the same time, as I told you, the multiple regression has other 3 uses. One is for the prediction purpose, another thing identifying the significant variables, and third thing is this what is called a prediction equation, identifying the significant variables and the exposure outcome relationship, adjusting the confounding variables.
Dr. Sarayu, I hope that you got answered to your queries. Now I hope all queries are answered. Yeah. Thank you, Dr. Sarayu. Thank you for feedback. Again, thank you so much for very knowledgeable and interactive session, sir. And our respected chairperson is not with us due to some urgent meetings. He's joined till mid of the session. And I thanks to our chairperson for chairing today's session. Now this is the end of today's session. We actually, on the behalf of Institute of Applied Statistics and National Institute of Ayurveda, we convey our sincere thanks to all the participants for their active participation and commitment for today's session. We heartily thanks the resource person of today's session, our respected Dr. Anil C. Mathew, sir, for describing the concepts of regression very briefly, and through the queries, he make the session more interactive. Again, thank you so much, sir, for your valuable time and with sharing your experience and about the session with the participants. Now, this is the end of today's session. Tomorrow we have one more session. This is a practical session. Tomorrow we have one practical session start using Microsoft Excel delivered by Dr. Dushyant Tyagi sir. So join tomorrow at 6 p.m. This is the end of today's session. We again thanks to all dignitaries and all participants participating in today's session. Thank you so much, sir. Thank you so much.
Yeah, I also really enjoyed the 2 days with you. Thank you.
Thank you so much. Thank you. This is the end of today's session. I thanks again to all participants.